Under the dark canopy of the night, everything feels vast, yet contained. The stars glitter like distant promises, and somewhere in that silent expanse, we believe we know where the universe ends. But what if that belief is an illusion? What if this universe, everything we've ever known, every atom that has ever loved, lived, or died, is just one fragile line in an endless cosmic book? Imagine the entire night sky fading away, only to reappear again, copied infinitely, each version slightly altered. Galaxies rearranged, stars burning in strange colors, a sky where gravity is weaker, time moves sideways, and life blooms from elements we can't even name. This is not science fiction. It's a question that breaks reality itself. Could our universe be just one of countless others? Could there be an infinity of worlds, some almost identical to ours, others entirely alien, scattered across a higher dimensional sea we cannot see, touch, or measure? The thought sounds impossible, almost blasphemous to our sense of uniqueness, and yet some of the greatest minds in physics now whisper that it might not only be possible, it might be inevitable. The seeds of this idea were planted not in imagination, but in mathematics. The equations that describe our cosmos, elegant, intricate, almost divine in their precision, also seem to hint that reality doesn't end with us. When scientists trace the laws of physics back to their roots, when they rewind the film of existence to its very first frame, they find something unsettling. There's nothing in the equations that says the universe must stop at one. In fact, those equations suggest it may be natural, even necessary, for many universes to exist. Picture our universe as a single soap bubble suspended in an infinite cosmic foam. Around it, billions of other bubbles shimmer, expanding, colliding, birthing, and dying in silence. Each bubble holds its own version of space and time. In one, gravity crushes stars before they can shine. In another, atoms never bind, and the story of life never begins. In yet another, there could be a world where you exist, but chose a different path. A heartbeat out of sync, a thought that led elsewhere, a universe split by decision. It sounds fantastical, but our best theories of physics keep leading us here. The Big Bang, the Great Beginning, might not have been a single event. It could have been one of countless explosions across an eternal inflating sea of quantum energy, a vast field constantly bubbling with new universes. What we call the beginning might have been merely the local ignition of one region among endless others. If that's true, then the night sky above us is not a boundary. It's just the inside wall of our bubble, beyond which lie others, unreachable, unseen, yet real. Why would scientists take such an outrageous possibility seriously? Because every time we push deeper into the structure of reality, simplicity vanishes, replaced by strange abundance. Quantum mechanics taught us that particles can exist in many states at once, here and not here, alive and dead, until observed. Cosmic inflation showed that the early universe could expand exponentially, spawning separate regions that never reconnect. String theory, in turn, suggests a landscape of possible universes, 10 to the power of 500 different versions of reality, each defined by different physical constants. Taken together, these ideas don't merely allow the multiverse, they almost demand it. But behind the equations lurks a deeper question, one that science alone cannot silence. If infinite universes exist, what does that make us? Are we a deliberate note in an endless symphony, or just the echo of randomness repeating forever? The human mind was never built to think in infinities. We crave edges, beginnings and ends, cause and effect. Yet the multiverse erases those boundaries. It suggests that every possible version of reality may already exist somewhere. Every dream realized, every disaster averted, every life unlived. All floating in endless, indifferent repetition. The thought is both beautiful and terrifying. If everything that can happen does happen, what becomes of meaning? Does morality survive in a reality where every choice is made somewhere else? Or are we simply characters reciting lines written in countless other worlds, unaware of the infinite audience beyond our stage? In one universe, you're watching this video. In another, you've never heard of it. In another still, the very concept of video doesn't exist because light behaves differently. Time bends another way, and consciousness itself never emerged. Our place in this grand speculation is fragile. We are beings of dust, asking questions about the ocean while standing on a grain of sand. And yet, that's what makes us remarkable. Against all odds, in this one universe among possibly infinite others, we developed the capacity to wonder, to stare at the sky and ask, what lies beyond the edge of existence? Perhaps that curiosity itself is the bridge between worlds. Maybe in every universe, intelligent life reaches this same question, gazing out and realizing the same humbling truth, that the universe they see is never the whole story. For now, the multiverse remains unproven, its edges hidden behind horizons we may never cross. But even as a hypothesis, it shakes the foundation of everything we think we know. If our cosmos is just one bubble among many, then the universe isn't a closed book. It's a library without walls. Somewhere, pages are being written right now, each filled with different stars, different fates, and different versions of you. And if that's true, if existence truly extends beyond our sight, then perhaps the greatest discovery of all is not that we are alone in our universe, but that there may be no such thing as our universe at all. Underneath the quiet elegance of the night sky lies a secret so vast it almost feels forbidden. A secret born not from imagination, but from equations. Our universe, the one that holds your heartbeat, your memories, every atom that ever existed, might be only one in a swarm of universes, 10 to the power of 1,000 or more, each blooming from the same mysterious fabric of creation. It wasn't poets or philosophers who first stumbled upon this possibility. It was physicists, armed with mathematics so precise it began to reveal something terrifyingly infinite. They weren't looking for other universes. They found them by accident. At the dawn of the 20th century, Albert Einstein wrote an equation that changed everything. A few symbols that linked space, time, matter, and energy into a single cosmic dance. His general theory of relativity described how mass bends the geometry of space, how energy curves the flow of time. To Einstein, the universe was like a vast stage where space and time were not static backdrops, but flexible, living entities. But his equations carried a disturbing implication. The universe couldn't stay still. It must either expand or collapse. The cosmos itself was dynamic, alive. Einstein, ever cautious, didn't like that conclusion. He added a cosmological constant to keep the universe static, an invisible force to counter gravity's pull. He called it a mathematical fix. Later, he would call it his greatest blunder. Because when Edwin Hubble peered through his telescope in 1929 and saw galaxies rushing away from us, it became clear that the universe was indeed expanding. Einstein's equations had been right all along. Space was stretching, dragging galaxies with it. But that discovery only deepened the mystery. If the universe is expanding, then at some point in the past, everything must have been closer together, infinitely close. There must have been a beginning. The Big Bang Theory emerged from this realization, a model in which the entire universe was born from a single, unimaginably dense point that exploded outward, cooling, spreading, and eventually forming stars, planets, and life. For decades, this seemed to be the full story. A singular beginning, a finite history, a single universe. But deep inside that simplicity, something didn't add up. The cosmic microwave background, the faint afterglow of the Big Bang, appeared too smooth. Regions of space too far apart to ever have exchanged information looked identical in temperature and structure. It was as if the universe had been ironed flat and uniform before it ever had time to communicate. How could that be? In the late 1970s, a young physicist named Alan Guth was puzzling over this very problem. One winter night, he scribbled a note in his notebook. Spectacular realization. What he realized would shake cosmology to its core. Guth proposed that in the first trillionth of a second after the Big Bang, the universe underwent a sudden, violent expansion, a moment of exponential growth he called inflation. In that fleeting instant, space itself ballooned at speeds faster than light, stretching tiny quantum fluctuations to cosmic scales. The result was a universe smooth enough to match the microwave background, yet seeded with the minute irregularities that would later form galaxies. It was a triumph, a simple idea that explained a long-standing mystery. But buried within it was something even stranger. Inflation, Guth realized, might not have ended everywhere at once. Quantum mechanics, the restless uncertainty that governs the microscopic world, means that the inflationary field, the energy that drove this expansion, could decay at different times in different places. In some regions, inflation would stop, birthing a bubble universe like ours. In others, it would continue, space still expanding, still boiling with potential. This led to a staggering conclusion. Inflation wasn't a single event in the past. It might be eternal. The cosmos could be endlessly creating new universes in a vast, ever-growing multiverse. Imagine it. Space as a churning ocean of energy, inflating eternally. Within it, countless bubbles form and detach, each expanding into its own universe with its own space, its own time, its own laws of physics. Our universe, with all its stars and galaxies, would be just one bubble drifting in that infinite foam. Around us, other bubbles collide, merge, vanish. Some might contain no matter at all. Others might harbor strange physics, where light curves back upon itself, or where gravity repels instead of attracts. The Big Bang, once thought to be the beginning of everything, becomes merely a local event, one spark in an eternal storm of creation. The numbers are mind-breaking. According to some estimates, there could be as many as 10 to 100,000 universes. Each bubble's constants, gravity, electromagnetism, quantum behavior, could differ, leading to entirely distinct realities. Some of these universes might be short-lived, collapsing seconds after birth. Others might expand forever, forming galaxies and civilizations. It's a cosmic lottery on an unimaginable scale, and by sheer probability, somewhere among that infinity, one universe would have just the right conditions for life. Ours. To physicists, this idea wasn't born out of fantasy, but necessity. Inflation solved too many problems to ignore. It explained why the universe is flat, why it looks the same in every direction, why no relic magnetic monopoles exist. But it also refused to die. The mathematics of inflation naturally lead to eternal inflation. And with eternal inflation comes the multiverse. Not as speculation, but as consequence. Once inflation begins, it never completely ends. Somewhere, new universes are always forming. The Big Bang never truly stops. The deeper physicists looked, the more inevitable it became. Even the vacuum, the supposed nothingness of space, is unstable. Quantum fluctuations, tiny tremors in the void, constantly create and destroy virtual particles. It's as if the universe itself can't sit still, constantly bubbling at the edges of existence. If such fluctuations could birth our universe, what prevents them from birthing others? When vacuum energy becomes unstable, it decays into something new. A new pocket of space-time, another universe. This picture of eternal inflation blurs the very idea of a beginning. There was no single first moment, just an infinite cascade of births. Each bubble might believe itself to be the original, unaware of the ocean beyond. In this view, our cosmos is like a single firework in an endless cosmic finale, unaware that countless others explode all around it, forever. And yet, with all its elegance, the theory carries philosophical weight. If there are infinite universes, does that mean every possible configuration of matter exists somewhere? Somewhere else? There might be a version of you reading this sentence in reverse, or one where human civilization never formed at all. It raises a chilling thought. In infinity, every possibility is realized. Randomness itself loses meaning. There is no chance, no uniqueness, only inevitability. Physicists like Andrei Linde and Alexander Vilenkin carried Guth's idea further, developing models of chaotic inflation and eternal creation. Linde compared the multiverse to a growing fractal, an infinite, self-replicating structure in which universes give rise to new universes endlessly. Every cosmic bubble could spawn others within it, like seeds germinating in an infinite field. To him, the multiverse wasn't a side effect. It was the natural state of reality. The universe, he said, is not just one thing. It's everything, all possibilities happening somewhere. But how do you prove something you can never see? That question haunts cosmology. Our universe's horizon, the limit of what light can reach us, is finite. Beyond that, we cannot observe. The other bubbles, if they exist, lie beyond all possible reach. Yet, there are hints. Tiny anomalies in the cosmic microwave background could be scars of collisions between universes, faint imprints of neighboring bubbles brushing against ours in the distant past. Some physicists even propose that black holes might be gateways to new universes, their singularities acting as cosmic wombs, birthing fresh space-time. Each of these ideas stretches the fabric of reason, but the math keeps whispering, this is how it must be. The multiverse emerges not from desire, but from inevitability. Once inflation begins, once quantum fluctuations are admitted, the creation of other universes becomes unavoidable. The universe isn't a single event. It's a process, a living, breathing expansion with no end. Still, such infinity forces us to question what real even means. If every possible version of reality exists, what anchors us here? Are we special, or simply statistical noise in an endless storm? The thought is both humbling and horrifying. It suggests that meaning might not be written into the cosmos itself, but constructed locally, by fragile beings aware of their own insignificance. Perhaps our need for meaning is what defines this universe, the one where consciousness rose high enough to look outward and ask why. Physicists continue to refine the mathematics. New generations of telescopes probe the cosmic microwave background for fingerprints of inflation, searching for the faint polarization patterns, the B modes, that would confirm its violent birth. If found, they would not only prove inflation, but hint at the multiverse beyond. And if they are never found, the mystery remains, an unsolved edge between physics and philosophy. It's ironic. In trying to understand how our universe began, we may have discovered that it never truly began at all. Each answer opens another door, each equation another universe. What started as a quest to explain the smoothness of the sky may end in the realization that the sky itself is only one of countless skies. Reflections within reflections, forever receding. And so we return to the haunting question, if inflation created other universes, where did it begin? What sparked the first field, the first expansion, the first bubble in this endless foam? Science, for all its brilliance, may never know. The equations describe how, but not why. Somewhere beyond our horizon, new universes are still being born, their skies unfolding, their stars igniting, unaware of us, just as we are unaware of them. Perhaps that's the final irony of existence. In an infinite multiverse, we will never find the center because there is no center. Creation never started. It is still happening, everywhere, all the time. Every decision you've ever made, and every one you never did, might still be unfolding somewhere. Somewhere, there's a version of you who said yes instead of no. A version who stayed instead of leaving. One who never met the people you know, never spoke the words you've spoken, yet still walks through a life that feels as real to them as yours does to you. Every possibility, every thought, every quantum flicker may have carved its own branch of reality, not metaphorically, but literally. If that's true, then you are not one being moving through a single world. You are an infinite collection of selves, scattered across an endless sea of possibilities. This is the unsettling promise of the quantum multiverse, a theory born not from speculation, but from the strange and stubborn rules that govern the smallest things in existence. When physicists first looked into the quantum realm, they found a world that defied all logic. Particles that could exist in multiple places at once, waves that interfered with themselves, electrons that seemed to make decisions only when someone looked. It was a universe of ghosts, shimmering probabilities that collapsed into reality only through observation. For decades, no one could fully explain it. The mathematics worked flawlessly, predicting experiments with extraordinary precision. But the meaning behind the equations was a riddle. How could an atom be in two states at once? How could a photon pass through two slits simultaneously? The answer seemed to depend on us, on the observer. It was as if reality itself waited for consciousness to decide what existed. Niels Bohr, one of the founders of quantum theory, suggested that particles don't have definite properties until measured. Before observation, they exist only as a superposition, a blend of all possible outcomes. When observed, one outcome becomes real, and the rest vanish like smoke. But not everyone could accept that the universe depended on our gaze. In the 1950s, a young physicist named Hugh Everett III proposed a radical alternative, one that would forever change how we think about existence. What if, Everett said, all the possible outcomes of a quantum event actually happen? What if reality doesn't collapse into one version? It splits. Each possibility unfolds in a separate, parallel universe. When a photon chooses which slit to go through, it goes through both, one in each branch. When you flip a coin, one world sees heads, another tails. When you choose a path in life, another you takes the other road. Everett called it the many worlds interpretation. At first, his peers dismissed it as absurd. It sounded like science fiction, an infinite duplication of universes for every quantum event, every heartbeat. But mathematically, it made perfect sense. Quantum equations describe a wave function, a vast field of probabilities that evolves deterministically. Nothing in the math says that probabilities collapse. The collapse was something physicists added by hand, just to match what they observed. Everett removed that assumption. He said the wave function never collapses. It simply branches. In this view, the universe doesn't make choices. It includes all choices. Every time a quantum event occurs, which is constantly, reality divides. One branch where the particle spins up, another where it spins down. One where the cat in Schrödinger's famous thought experiment lives, another where it dies. Both are real, equally valid, but forever separated. Decoherence, the process by which quantum superpositions interact with their environment, ensures that the branches never meet again. They become isolated, distinct realities, invisible to each other. The implications are dizzying. In this multiverse, there are endless versions of you, each following a different path through existence. Every hesitation, every impulse, every decision spawns new universes. You become a fractal, a pattern repeating endlessly across dimensions. Somewhere, you're an artist. Somewhere, you're a scientist. Somewhere, you never existed at all. Infinity isn't out there among the stars. It's right here, unfolding inside your every moment. To grasp how profound this is, imagine standing before a wall of mirrors stretching endlessly in all directions. Each reflection shows a slightly different version of you, a different pose, a different emotion, a different lifetime. The mirrors extend beyond sight, curving into infinity. The many worlds interpretation suggests that these reflections aren't illusions. They are as real as the one looking back now. Every reflection believes it is the original, unaware of the infinite others. Quantum physics forces us to confront the idea that reality might not be a single thread, but a tapestry woven from infinite strands. The act of living, of observing, deciding, and existing doesn't narrow possibilities. It multiplies them. The universe isn't choosing for you. It's keeping every version of your choice. You never destroy possibilities. You only separate from them. But this raises a haunting question. If every version of reality exists, which one is real? For decades, physicists and philosophers have wrestled with this paradox. If every universe is equally real, then real itself loses meaning. Reality becomes the set of all possibilities, and the sense of being one consciousness traveling through one timeline becomes an illusion, a byproduct of memory and continuity. Your awareness simply rides one branch of the wave function, tracing a single path through the infinite maze. To you, it feels complete. But in truth, every other you, living out every other outcome, feels just as complete. This isn't just abstract theory. It emerges from real mathematics and experiments. Quantum superposition is not a metaphor. It's observed. An electron truly behaves as if it travels multiple paths until measured. The interference patterns we see in double-slit experiments are proof that these overlapping possibilities coexist. The many worlds view simply takes that coexistence seriously. Instead of asking how one reality emerges, it declares that none do. They all persist. And if they all persist, then existence is far stranger than we can imagine. Somewhere in the quantum foam of possibility, every story you could ever live is already written. Every regret you've carried, every dream you've abandoned, has unfolded somewhere else. You might think of yourself as a single being, but you're more like an ocean. Each drop a separate self, each wave a different life, all connected by the same underlying sea of quantum potential. This concept blurs the boundary between science and philosophy. It asks us to rethink identity itself. If there are infinite versions of you, each believing they are the original, then what makes you, you? Is it your body, your memories, your particular thread of consciousness? And if consciousness arises from quantum processes in the brain, could it too be splitting? Countless minds diverging with every passing moment, each unaware of the others? Perhaps the self is not a single flame, but 1,000 sparks, flickering in parallel. The thought can be unsettling, even existentially painful. It means every triumph you celebrate might be mirrored by another you's failure. Every life you cherish might be one among infinite variations. The universe, in this sense, is not kind or cruel. It's complete. It contains all possibilities, all outcomes, without judgment. And yet, there's beauty in that completeness. Because in this vast multiverse of choices, nothing is ever truly lost. Somewhere, there is always a version of you who said the right words, who held on longer, who found peace. Somewhere, love never ended. Somewhere, pain never began. Every act of kindness, every spark of hope, exists eternally in some branch of reality. The many worlds interpretation may sound cold, but it offers a strange kind of immortality, not of bodies or souls, but of possibility. Still, we cannot escape the human need for meaning. If everything happens, then why strive? Why care? If there's a universe where you succeed and another where you fail, does effort matter? Perhaps meaning doesn't come from the outcome, but from the awareness of choice itself. We live in the branch we perceive, and within it, Our decisions shape the experience of that world. The existence of other branches doesn't erase this one. It simply enriches the idea that existence is larger than we can comprehend. As physicists explore deeper, they find that the quantum and the cosmic may not be so separate after all. The same mathematics that governs particles might govern entire universes. Each universe could be a quantum fluctuation of a higher dimensional reality, a cosmic wave function branching eternally. We might be living inside a quantum equation, a self-sustaining pattern of probability that never truly collapses. In that sense, the multiverse isn't somewhere far away. It's here, in every particle, every atom, every choice. The infinite isn't above us, it's within us. But if that's true, if every world exists, every outcome unfolds, then what does it mean to be alive in just one? Why are we aware of this branch and not the others? Some physicists suggest that consciousness itself is a kind of filter, a collapse not of the wave function, but of awareness. Our minds can only perceive one timeline at a time. We experience continuity not because it's the whole truth, but because our biology demands coherence. The rest of reality, the infinite mirrors, remain unseen. And yet, sometimes, through dreams, déjà vu, intuition, or the faint pull of regret, we feel the shimmer of those other paths. The moments we say, "what if," are echoes of universes where "what if" actually happened. The longing for other possibilities might be the faint memory of our infinite selves, reaching across the quantum veil. Ultimately, the quantum multiverse forces us to face the deepest paradox of existence. We are both infinite and singular. We are the sum of all possible selves, yet only one lives this particular life. The many worlds theory doesn't destroy the self, it magnifies it. It shows that within every human heart lies a cosmos of possibilities, a branching infinity of love, loss, courage, and choice. Perhaps that's the truest reflection of reality. Not a universe of things, but a universe of becoming. Every instant, new branches unfold. Every heartbeat creates new worlds. The universe doesn't decide which story is real. It tells them all. And we, in our smallness, are the storytellers within it, walking paths that split endlessly, never knowing how many versions of us walk beside us in silence. Somewhere, gravity might repel. Somewhere, time might flow backward, stars unforming into dust, dust unraveling into energy. Somewhere, there could be no atoms, no light, no time, only silent equations humming through void. And yet, every one of these strange worlds could be as real as ours. Not imagination, not myth, but consequences of the mathematics buried within the deepest theories of modern physics. According to string theory, reality might not be one universe, but a landscape of 10 to the power of 500 possibilities. A cosmic library so vast that every conceivable law of nature, every pattern of existence, might be written in one of its volumes. It began as a quest for unity, the dream of a single equation to describe everything. In the 20th century, physics had split into two great pillars: general relativity, Einstein's majestic description of space, time, and gravity, and quantum mechanics, the strange probabilistic language of the subatomic world. Each was breathtakingly successful and utterly incompatible. Relativity ruled the stars. quantum theory ruled the atoms, and between them yawned a contradiction no one could bridge. At the smallest scales, relativity broke apart. At the largest, quantum theory dissolved into nonsense. The universe seemed to follow two sets of rules that refused to meet. String theory was born from that fracture, a desperate attempt to weave the two into one coherent fabric. Its premise was audaciously simple. What if the fundamental particles of the universe, electrons, quarks, photons, were not point-like dots, but tiny vibrating strings of energy? Like the strings of a violin, each vibration produced a different note, a different particle. Matter and forces were simply different harmonies of the same underlying instrument, the cosmic string. The beauty of this idea was that it naturally included gravity. When the mathematics was worked out, one of the string's vibrational modes corresponded perfectly to a particle that behaved like the graviton, the long-sought quantum messenger of gravity. Suddenly, physicists had in their hands something miraculous, a theory that unified quantum mechanics and relativity. The universe wasn't a random collection of particles and forces. It was a symphony, every atom a note in an infinite composition of vibration. But beauty came at a price. For the equations of string theory to make sense, the universe couldn't have just the 3 dimensions of space and 1 of time we perceive. It required more, 10 dimensions in total. These extra dimensions weren't visible because they were curled up, compactified, hidden within the fabric of reality at scales far smaller than any microscope could reach. We move through 3 dimensions, but within each point of space, 6 more dimensions might be folded in intricate geometries. Tiny loops, spheres, and shapes called Calabi-Yau manifolds. Each configuration defines a different way for strings to vibrate, and therefore a different kind of universe. Out of this realization came a breathtaking insight. If the shape of these hidden dimensions can vary, then the laws of physics themselves can vary. The strength of gravity, the mass of the electron, the speed of light, all depend on how those extra dimensions are folded. In one shape, gravity may dominate. In another, electromagnetism might rule. One configuration might permit chemistry and life. Another might dissolve in chaos. The equations didn't yield a single universe. They yielded a vast landscape of possible ones. Physicists began to call this the string landscape. Each valley, each peak of that mathematical terrain represented a different vacuum state, a stable configuration of energy where a universe could form. There could be 2,500 such vacua, perhaps even more. 10 to the power of 500 different universes, each obeying its own set of physical laws. To grasp that number is impossible. It's more than all the atoms in all the stars in the observable universe, a scale so large that probability itself loses meaning. In this cosmic landscape, universes aren't created by whim. They arise from the very structure of reality. Picture a boundless sea of potential energy, rippling and fluctuating at the smallest scales. As it cools, it condenses into bubbles, each bubble settling into a different vacuum state, each becoming a separate universe. Some expand, some collapse, some freeze. Each bubble is sealed off from the others, floating on the higher dimensional ocean that birthed them. This is not mere metaphor. It's the natural consequence of the equations that describe string theory's multidimensional geometry. But what lies beyond these bubbles? String theory evolved into something even more ambitious. M-theory, the mother of all string theories. It proposed that strings themselves might be just one-dimensional slices of higher-dimensional objects called branes, short for membranes. A brane can have many dimensions. A two-dimensional brane is like a sheet, a three-dimensional brane like a volume, and so on. Our entire universe could be one such three-dimensional brane, floating in a vast higher-dimensional space. The bulk, everything we know, matter, light, galaxies, could be confined to our brain, while gravity, the most ghostly of forces, seeps weakly into the bulk, explaining its puzzling weakness in our world. In this vision, the multiverse becomes almost tangible. There could be countless branes, each one a separate universe, drifting like cosmic rafts through an invisible ocean of higher dimensions. Sometimes these branes might drift close and collide, and when they do, the energy of that collision could ignite a big bang, birthing a new universe in the aftermath. Our own cosmic beginning might have been such a collision. Two branes brushing together in the dark, unleashing space, time, and matter. Imagine the scene. Vast sheets of energy, undulating in 11-dimensional space, rippling like flags in a cosmic wind. When they touch, entire universes flare into being. Each collision, each vibration, each fold gives rise to a new cosmos, expanding, cooling, and birthing stars. The multiverse becomes a living, breathing thing, a boundless ecosystem of creation. And yet, behind this grandeur lies deep uncertainty. The mathematics of string theory are exquisite but untested. No experiment has yet confirmed the existence of extra dimensions or vibrating strings. The energies required to probe them are far beyond anything humanity can produce. For now, string theory remains a map without landmarks, a vision of infinite possibility drawn on the edge of reason. But even as speculation, it reshapes our understanding of reality. It tells us that the universe might not be fine-tuned by design or coincidence, but simply because out of infinite possibilities, we inhabit the one where life can exist. This idea, known as the Anthropic Principle, is controversial, even unsettling. It suggests that the reason our universe seems perfectly calibrated for stars, chemistry, and consciousness isn't special at all. In the cosmic landscape of 10^500 universes, most are sterile. A few, by sheer chance, have the right constants to permit complexity. We exist not because the universe was made for us, but because we arose in one of the rare universes where we could. It's a humbling thought, one that replaces meaning with mathematics, purpose with probability. And yet, there's a strange kind of comfort in it too. The multiverse becomes a mirror of nature's boundless creativity. Where one world ends, countless others begin. Where one set of laws falters, another takes its place. Reality is not fragile. It is inexhaustible. Still, we can't help but wonder, if these other universes exist, could we ever touch them? Could we ever know? The boundaries between branes, if they exist, might be unimaginably distant. But some physicists speculate that their gravitational influence could be faintly detectable. Tiny deviations in the cosmic microwave background, subtle patterns of polarization left over from collisions in the early multiverse. Others suggest that miniature black holes, created in particle accelerators, could reveal the fingerprints of extra dimensions, offering indirect proof that our universe floats in a larger sea. If such evidence were found, it would mean the multiverse is not just philosophy, but physics. We would be living inside one universe among countless others, each with its own story, its own constants, its own birth. The dream of a theory of everything would dissolve into a theory of every possible thing. But even if proof never comes, the implications remain profound. String theory's landscape redefines creation itself. It says that infinity isn't an anomaly, it's the default. That what we call the universe is just one drop on an invisible string, one note in an eternal vibration, and that somewhere beyond our reach, the strings still sing, weaving new realities into being, forever. Perhaps, in the end, the greatest revelation of all is not that we are small, but that existence itself refuses to be limited. The more deeply we search for the fundamental building blocks of reality, the more we find that the foundation has no bottom, only endless variations, infinite symmetries, and unending creation. In the cosmic landscape of string theory, there is no final universe, no ultimate truth, only the endless resonance of possibility. Universes vibrating like dew drops on invisible strings, shimmering in the dark, each reflecting the light of all the others. The edge of our universe may already bear burn marks from another. Somewhere, in the oldest light we can see, the afterglow of creation itself, there may be fingerprints not of our cosmos, but of something beyond it. Ripples too perfect, circles too smooth, shadows that don't belong. For decades, astronomers have stared into this faint cosmic haze, the whisper left behind by the Big Bang, and wondered if they are looking at a scar, the echo of another universe brushing against ours long before stars were born. It sounds impossible, but the deeper we look, the more the data seems to tease us. The cosmic microwave background, or CMB, is the oldest image of the universe. Light released roughly 380,000 years after the Big Bang, when the first atoms formed and the cosmos became transparent. It's a snapshot of the universe's baby face, still hot and glowing from its birth. And like a forensic map, it preserves every tiny imperfection, every ripple in temperature, every fluctuation that would one day grow into galaxies and clusters of stars. When scientists first mapped this background radiation with satellites like COBE, WMAP, and later Planck, they found something breathtaking. The universe is astonishingly uniform. No direction appears special. Yet amid that smoothness, they also found anomalies, subtle patterns that didn't fit, cold spots larger than expected, temperature gradients with no clear cause, faint rings in the data, like overlapping ripples spreading across a still pond. One of these anomalies, called the cold spot, became famous. Discovered in the early 2000s in data from the Wilkinson Microwave Anisotropy Probe, it appeared as a vast region of unusually low temperature, stretching across hundreds of millions of light-years. Some scientists suggested it was caused by a supervoid, a region with fewer galaxies, allowing light to lose energy as it passed through. But others proposed something far stranger, that it might be the bruise left by another universe colliding with ours during the early moments of inflation. If inflation is true, if the multiverse is an endless sea of expanding bubbles, then collisions between these bubbles should occasionally happen. When two universes meet, their walls would compress and release energy, distorting space-time and leaving circular imprints in the cosmic microwave background. Each collision would be a cosmic scar, an overlapping ring on the sky. Detecting such a pattern would be the first tangible sign that our universe is not alone. In 2011, a team of physicists from the University of London, led by Stephen Feeney, analyzed CMB data using advanced algorithms to search for these circular signatures. Their results were electrifying. They claimed to have found several regions with features consistent with bubble collisions. The media erupted. "Evidence of other universes found," the headlines read. For a brief moment, it seemed that the multiverse had stepped out of theory and into observation. But science is cautious. Other teams examined the same data and found that the anomalies could just as easily be statistical noise, random fluctuations in a chaotic universe. The signal was tantalizing but inconclusive. The cold spot remained unexplained, neither confirmed nor dismissed. A mystery suspended at the edge of proof. Still, the search didn't stop. NASA's Planck satellite, launched in 2009, delivered the most precise map of the cosmic microwave background ever made. A portrait of the early universe with unprecedented clarity. Planck's data revealed even subtler irregularities, asymmetries in temperature and polarization that defied expectations. Some physicists argued they were artifacts of cosmic variance, the randomness inherent in finite observations. Others whispered that the fingerprints were too consistent, too deliberate. Maybe, they suggested, we were seeing the faint outlines of universes beyond our own, overlapping realities bleeding through the veil. And then came the James Webb Space Telescope, humanity's most powerful window into the cosmos. While its mission wasn't to hunt for the multiverse, its vision, deep, infrared, ancient, has begun to uncover galaxies so old, so massive, that they defy the standard timeline of cosmic evolution. Some appeared too soon after the Big Bang, too developed to fit the models. It's as if they came from somewhere else, as if our cosmic story began in the shadow of another. Could these be echoes of collisions, artifacts of universes merging? It's speculation, yes, but not without reason. If the multiverse exists, its effects should be subtle but cumulative. A gravitational tug here, a pattern of polarization there. Tiny hints that space itself has been disturbed by neighbors beyond sight. Physicists are beginning to map these possibilities. One team proposes that primordial gravitational waves, ripples in space-time created during inflation, might carry imprints of collisions between universes. Detecting them could be the Rosetta Stone of the multiverse, translating theory into evidence. Projects like BICEP, LIGO, and future missions such as Lightbird and CMB-S4 are all searching for these waves. Not the ones from colliding black holes, but from the earliest fractions of a second after creation. If inflation is eternal, those waves might bear scars, oscillations too large, too complex to belong solely to our universe. The problem is sensitivity. These signals are faint, buried beneath cosmic noise, like whispers lost in an endless storm. Even so, the possibility persists. We might already be seeing the multiverse without realizing it. Not as distinct universes floating beyond our reach, but as subtle fingerprints woven into the fabric of our own. The patterns in the sky, The distribution of galaxies, even the structure of space-time itself, could all be quiet records of collisions long past. Each anomaly, each unexplainable pattern becomes a clue, yet beneath the data lies an older, more human struggle, the tension between proof and faith. The multiverse demands evidence, but the evidence may forever lie beyond our horizon. We can only see as far as light has traveled since the Big Bang. Anything beyond that, other universes, other inflating regions, remains hidden by cosmic geometry. To glimpse them would require traveling faster than light, or waiting longer than the age of everything. And so, for now, we search for shadows, reflections of infinities we cannot touch. Still, science has always advanced by chasing the invisible. We once couldn't see atoms, only inferred them from their fingerprints. We couldn't see black holes, yet their gravity betrayed them. Perhaps the multiverse is the next invisible truth. Not a separate dimension we'll travel to, but a framework we'll recognize through its consequences. A shadow cast by something unimaginably vast. If our universe has ever collided with another, the evidence might already be written in its geometry. Some cosmologists suggest that dark energy, the mysterious force accelerating the expansion of the cosmos, could be a residual effect of neighboring universes tugging on ours. Others propose that the asymmetry of matter and antimatter, why there's more of one than the other, might be the fossil of an ancient interaction with another cosmos. In every corner of modern physics, whispers of the multiverse seem to echo, faint but persistent. And what if the collisions never stopped? If new universes continue to form and expand in the higher dimensional sea of inflation, then the story of creation isn't finished. It's still happening, not just in the past, but right now. Somewhere beyond our cosmic horizon, bubbles of new reality are still being born. And just as ours once collided to shape its edges, another could someday approach again. The thought is both terrifying and sublime. If universes can collide, then ours could end the same way it began. Not in isolation, but in contact. The next collision wouldn't come with warning. It wouldn't burn or explode. It would rewrite the very laws of physics, turning everything familiar into something unrecognizable. In the instant of impact, our space and time would merge with another's, birthing something new, a universe within universes, an echo of creation repeating itself. But maybe that's the destiny of all things, not to end, but to transform. The multiverse, in its boundless indifference, may not destroy meaning, but redefine it. Just as stars die to forge heavier elements, perhaps universes collide to seed new realms, each inheriting fragments of the ones before. The shadows we see in the cosmic background could be the ghosts of our ancestors, the universes that came before ours, leaving behind faint, beautiful scars. So we continue to look. The telescopes reach deeper, the models grow sharper, and the whispers of other worlds grow louder. Whether we ever prove it or not, the evidence may already surround us. In the faint rings of microwave light, in the ripples of space-time, in the quiet knowledge that we might not be alone. Even at the edge of everything, because perhaps the greatest discovery of all is not that other universes exist, but that we are connected to them, not by travel or sight, but by origin. That every spark of light in our sky may be the reflection of a collision long past. A reminder that even creation itself happens in company. And if someday we find the scar, the true mark of another universe, it will not just be proof of the multiverse. It will be proof that existence itself is far bigger, far older, and far more beautiful than anything we can yet imagine. If every version of you exists, which one dreams this moment? Close your eyes for a second, and the universe continues. Stars burn, galaxies turn, space stretches endlessly, but within your mind, an entire cosmos unfolds in silence. Thoughts appear, memories shimmer, emotions rise like tides. And yet, none of this has weight or location. Consciousness floats between neurons, unanchored, invisible. If the multiverse is infinite, if every configuration of matter exists somewhere, then consciousness may be the strangest phenomenon of all. Because amid endless universes of rock, gas, and fire, only in a few does awareness bloom. Only in rare corners of infinity does the cosmos wake up and ask, "Why am I here?" This is where physics meets philosophy, and both begin to tremble. The multiverse doesn't just challenge our understanding of space or time. It erases the boundary between mind and matter. If everything that can exist does exist, then there are infinite versions of you having this thought right now. Infinite observers scattered through infinite worlds, all looking inward at the same question. What is the origin of awareness? And does consciousness itself play a role in shaping reality? To the ancient mystics, mind and cosmos were reflections of one another. Microcosm and macrocosm, one mirror gazing into another. Modern science, in its own strange way, seems to circle back toward that idea. Quantum mechanics, that slippery, unpredictable language of the subatomic, refuses to separate observer from observed. At the smallest scales, the act of measurement changes what is measured. Reality is not merely recorded, it is selected. Somewhere in that mystery, some physicists suspect, consciousness enters the equation. This idea remains controversial, even heretical, but it persists because the math itself invites it. The universe behaves like a probability wave until observed. And if observation collapses possibilities into a single outcome, then the mind, whatever it is, might be the interface between the many worlds and the one we perceive. Perhaps consciousness is not an accident within the universe, but a fundamental property of the universe. Maybe it doesn't emerge from matter at all, but rather, matter emerges within consciousness. If that's true, then you are not a passenger in the multiverse. You are part of the mechanism that defines which branch you experience. Every moment of awareness might be a thread woven through the infinite, linking the potential worlds that your consciousness selects from. Your choices, your perceptions, your very act of being could be the bridge between parallel realities, the quiet force that collapses the infinite wave of possibility into the singular life you call mine. But if infinity holds all versions of you, then what becomes of identity? Who is the I that asks the question? You may exist as countless selves, some heroic, some cruel, some entirely alien, each living out different permutations of your existence. Yet, they are not strangers. They are you. The multiverse dissolves the walls of individuality. It shows that you is not a single entity, but a pattern, a vibration repeating across realities. And within that realization lies both liberation and terror. Because in a multiverse, nothing is truly unique. Not your thoughts, not your actions, not even your soul. Everything that can be imagined exists somewhere. Every miracle, every atrocity, every joy and every heartbreak. The only thing rare, perhaps, is meaning. In infinity, rarity disappears. Only repetition remains. The philosopher's question, "Why am I me?" becomes even more haunting. Why this branch? Why this life among endless alternatives? If all possibilities occur, is there any significance to this specific path? Or is consciousness simply the random flicker of awareness, traveling one thread among billions, mistaking its own continuity for destiny? Some physicists have taken this further. If infinite universes exist, each representing every possible configuration of matter and energy, then statistically, most of those universes are not like ours at all. They are chaotic, empty, or hostile. And yet, somewhere in that vastness, pure chance could assemble a brain. Just a single conscious observer, floating in the void, complete with memories and sensations fabricated by randomness. This is the paradox of the Boltzmann brain. A self-aware entity arising spontaneously from entropy itself. In an infinite multiverse, such brains should vastly outnumber real, evolved beings. Which raises a disturbing question. How do we know we are not one of them? How do we know this world, this life, this memory of a body and a past, isn't an illusion conjured by statistical chaos? Perhaps every thought, every perception, is just a flash in a universe-sized hallucination, a consciousness momentarily coherent before dissolving back into disorder. It sounds like madness, but it flows logically from the mathematics of infinity. The more we try to quantify existence, the more it resists containment. The universe, it seems, may be a thought thinking itself, a loop of awareness reflecting endlessly through possibility. Some scientists dismiss this as philosophical noise. Others see it as the inevitable consequence of taking physics to its final frontier. In recent years, theories of quantum consciousness have gained cautious attention. The physicist Roger Penrose and anesthesiologist Stuart Hameroff proposed that quantum effects inside neurons might influence awareness, that microtubules within brain cells could maintain quantum coherence, linking consciousness to the fabric of reality itself. If true, this would mean our minds are not isolated biological events, but quantum instruments entangled with the universe. Awareness, then, could transcend the physical, not in a mystical sense, but as a property of space-time itself. If consciousness is quantum, then perhaps it doesn't just observe reality. It participates in it. It might even allow for a kind of resonance across branches, faint echoes between universes. A thought here could ripple there. A dream in one version of you could bleed into another, like two waves overlapping on a vast ocean. Déjà vu, intuition, or strange synchronicities. Maybe these are the shimmering interference patterns of minds that share a common origin across the multiverse. And if all realities are real, perhaps the deepest truth is that consciousness never truly ends. Death in such a framework is not annihilation, it's transition. The continuity of awareness might simply shift from one branch to another, like a river splitting into streams. Somewhere, another you awakens the instant this one fades, continuing the flow of experience without ever touching finality. In an infinite set of universes, consciousness might be eternal, not as a soul traveling worlds, but as the structure of existence itself. The simulation hypothesis adds another mirror to the maze. Some physicists and philosophers argue that if reality can be simulated in principle, if we can encode consciousness and physics within a computer, then, statistically, it's more likely that we're living in a simulation than the original reality. In a multiverse of infinite computational possibilities, our universe could be one layer among countless simulated layers, each unaware of the one above. Perhaps even the beings who programmed our world are themselves simulations, an infinite regression of minds, dreaming minds. In that sense, consciousness and creation become indistinguishable. To simulate a universe is to create one. To think is to birth a possibility. Every idea, every imagined world might exist somewhere as a realized branch in the infinite field of potential. The boundary between physics and thought dissolves. Reality becomes the sum total of all awareness observing itself. And yet, in this infinity of reflections, we return to the simplest mystery. What is the experience of now? Why this exact configuration of atoms, this exact sequence of memories, this precise feeling of existence? Science can trace the firing of neurons, the vibration of strings, the expansion of space, but not the spark that turns matter into meaning. That spark is the shadow science cannot measure, the ghost of awareness that makes reality real. If infinite versions of you exist, then perhaps the one reading these words is simply the one who became aware of them. In the countless branches where you never found this thought, this idea simply drifts unlit. Consciousness, in this way, could be the light that selects which path is seen, and maybe that's the answer hiding in plain sight. Consciousness isn't inside the universe. The universe is inside consciousness. Reality might be the dream of awareness, unfolding itself endlessly in all directions, creating worlds upon worlds just to know what it feels like to exist. The multiverse may not be a cold expanse of meaningless infinities. It might be the very process through which the cosmos experiences itself. If so, then meaning isn't rare after all. It's everywhere awareness touches, in the eyes of every creature, in every spark of curiosity, in every moment when a universe realizes it is alive. Perhaps that's why we look to the stars, not to escape our world, but to remember that we are the stars, dreaming. And if consciousness truly bridges worlds, then the final frontier isn't out there in the galaxies. It's here, within the quiet miracle of awareness. The one phenomenon that might ripple through every universe, binding them together in the only way infinity could ever make sense. Through the act of being. Maybe the multiverse isn't out there. Maybe it's what we are. From the beginning, humanity has looked up at the night sky and felt the pull of something greater. Long before telescopes or theories, we stood beneath the stars and sensed infinity pressing down. Vast, unknowable, and yet intimately familiar. Every civilization that ever lived has asked the same question in its own tongue. What lies beyond? Perhaps that question is older than language itself. It may be the echo of the universe remembering its own birth. A whisper from the cosmos through the minds that grew inside it. we have spent centuries peeling back the layers of existence, only to find that each truth reveals another mystery beneath it. First, we discovered that Earth was not the center of creation. Then we learned that our sun was one among billions, that our galaxy was one among trillions, that the universe itself might be only one bubble in an endless sea of others. Every time we think we've found the edge, it expands. Every answer opens into more questions. It's as if the universe keeps moving the horizon, daring us to chase it forever. And yet, in this pursuit of the infinite, we have uncovered something just as astonishing as the stars themselves: the reflection of our own minds. The multiverse, for all its breathtaking vastness, might be less about other worlds and more about the way we dream. When we imagine endless universes, we are projecting the same boundless creativity that made us paint, sing, and build. The idea that reality could contain every possibility is, perhaps, the ultimate expression of human imagination. The proof that consciousness, in its longing to understand, can conceive of infinity itself. Even if we never find proof, the search changes us. Because the moment we ask what lies beyond, we've already stepped past the limits of our own world. Every theory, every telescope, every equation is a bridge across the unknown. Whether the multiverse exists or not, the very act of reaching for it proves that something infinite already lives within us. Think of the generations who looked at the same stars, each believing they had reached the edge of knowledge. The philosophers of Greece, tracing circles in sand to model the heavens. The medieval astronomers who risked heresy to claim that the cosmos was larger than Scripture allowed. The physicists who uncovered the quantum world and found a mirror of infinity in the smallest particle. And now, we, creatures of stardust and mathematics, stand on the edge of understanding that reality itself may have no edge at all. It's tempting to feel small before such magnitude, to imagine that in an endless sea of universes, we must surely be insignificant. But perhaps the opposite is true. Maybe consciousness, this fragile light that flickers inside us, is the universe becoming aware of its own boundlessness. Maybe our wonder, our curiosity, our relentless need to ask questions is the multiverse speaking through us. We often picture infinity as something cold, a sterile expanse of endless repetition. But what if infinity is warm? What if it's alive, breathing through the countless forms of existence it contains? Every universe could be a thought, every thought a universe, each one beginning and ending in a cosmic rhythm too vast for us to hear, yet echoing through the deepest part of our being. Perhaps that is what consciousness truly is, the vibration of infinity folded into awareness. The more we learn, the less the line between out there and in here makes sense. The edge of the observable universe is not a wall, just as the edge of awareness is not the limit of mind. Beyond both lies mystery, the realm where imagination and physics blur. The multiverse, if it exists, is not simply a collection of other worlds. It's the ultimate reflection of potential. The idea that existence refuses to be confined to one version, one story, one truth. And maybe that's the real revelation. The multiverse is not a theory to be proven, but a mirror showing us that reality itself is infinite in its creativity. For every question we ask, the universe responds not with an answer, but with a new horizon. It teaches us that knowledge is not a destination. It's a journey that never ends. Imagine the cosmos now, as you read this. Galaxies drifting apart, new stars being born in the quiet dark. Somewhere, perhaps, another version of you is looking up at another sky, wondering the same thing. Somewhere else, another universe is just beginning, its constants barely settling, its atoms learning to dance. And somewhere even beyond that, existence itself is exhaling, folding infinity into new patterns, dreaming new realities into being. It's humbling to realize how temporary we are, and yet how eternal our curiosity seems to be. Our lives, brief as sparks, are woven into a fabric that stretches forever. Every heartbeat is synchronized with the pulse of creation. Every thought we have is, in some small way, part of the universe thinking itself into being. Perhaps meaning isn't something we impose upon the cosmos. Perhaps it's the cosmos expressing itself through us. If the multiverse exists, then we are not isolated. We are threads in a vast living tapestry. Countless variations of matter, energy, and thought, all interwoven into one endless story. We will never see all of it, never map the whole, but we were never meant to. The beauty lies in the pursuit, in knowing that the mystery remains, that there will always be more to discover. And if it doesn't exist, if there is truly only this one universe, this one fragile world, then that makes it all the more precious. Because even a single universe filled with consciousness, with life and love and curiosity, is miracle enough. Infinity doesn't have to mean countless worlds. It can also mean the endless depth of one. Maybe, in the end, the multiverse isn't a question of physics at all. Maybe it's a question of perspective. Infinity may not be a realm we travel to, but a truth we awaken to. The realization that existence is vast, not because it contains everything, but because it is everything. Every moment, every breath, every flicker of awareness is part of that vastness. So perhaps the story doesn't end here. Perhaps it never does. The universe expands, consciousness deepens, and together they form a loop. Infinity folding back into itself, beginning again as it ends. The cosmos exhales, and in that breath, new worlds are born. And somewhere within that endless rhythm, a single question still echoes, soft, ancient, and unanswerable. What lies beyond? Maybe the answer is this: there is no beyond. There is only the infinite dreaming itself through us.